definitely tonight you will be doing.
Right, sir. Tomorrow morning I will.
Chidambaram, what is your cell number?
Oh, okay. I would share, sir.
Okay.
Yeah.
Arunachalam and I will, both of you, I will share tonight, maybe around 8:30, which day,
Sure,
time,
sir.
all those things, so that you will be able to pass on to your group. Okay.
Yes,
Sure,
sir.
sir. Sure.
Thank you, sir.
Thank you.
Thank you, sir.
We can start, sir.
Yeah, we'll start the class. I think time is left because you have to go home also again. Sometime you may be in the factory. Okay. So we are talking about diode, power electronic devices. Two classes are we talk. The power electronic devices, when you talk this means we are talking about semiconductor devices. Please note the electronics is there for the last 120 years. Started with valve, electronic valve or thermionic valves. Thermionic valves also had diode, it had transistors, correct? That is called as triode and pentode. The triode and pentode are equivalent to a transistor. Okay, so don't worry about that because that is no more. When I was doing my electronic BTech 42 years before, I studied that. That was only first chapter for me itself. For electronic student, first chapter will be a thermionic valve that was used valve, radio, radar. Electronics for 60 years they were ruling. In 1960s, they invented semiconductor diode and transistor in Bell Laboratories. Then it become they replaced the electronic valve, thermionic valves. Okay, compactness, lot of advantages. Now, after another 10-20 years, individual transistors were packed inside one single the wafer, silicon wafer. They started with something around 50 transistors in 1 square centimeter area, correct? Having thickness of few mm. Now, your Pentium processor, i7 processor, i10 processor has 10 million transistor within 1 square centimeters, correct? 1 square centimeter area, maybe 2 square centimeter area, having thickness of 5 mm. It has 10 million transistors. You can know a transistor, even now it is available. You would have seen, correct? Maybe generally they will be cylindrical shape with metal cap, body or plastics. I will show you when we talk about it. Now they pack millions in this one. The size of each transistor inside your Pentium processor, the volume of individual transistor in the nanometers, 10 nanometer cube, correct? That is what the size of individual transistor. They pack up to 10 to 20 million transistor in your i7 processor. Please note the i7 processor generally will look a square like this, a square this big, correct? This may be 2 centimeter or 1.5 centimeter. Generally, it will be yes rectangular. This one below that you will see around 100 to 200 pins, connect pin through which signals are passed. In which the center area, this is called as the package, correct? Package. Actual IC is only few, that is 1.2 centimeter, 12 mm or 14 mm is this. This may be 14 or 12, something like that one. I am trying. Maybe 20 mm. So square this one inside with, there are 20 million transistors, not lakhs, 20 million transistors packed in this, having thickness. And this, if you expose, this is called the actual chip, correct? Silicon chip, we saw that, or IC, integrated circuit. Correct name is integrated circuit. Colloquial name is chip. We see it different. This one, memory chips, CPU chips, or amplifier chip, all this thing. APAM, we studied last semester APAM in mechatronics. That is also chip only. Inside that itself, maybe thousands of transistors. In, say, MUA 741, APAM, we studied, correct? Last semester, there is APAM, in which around 25 transistors were there. Please note that this was the first IC, integrated as an analog IC, invented in 1960s. That time around 25-30 transistors inside. I showed you the internal diagram also, correct? Now, but inside your Pentium, the i7 processor, all those things, i10, you have 20 million transistors. Why I'm saying is, they're all called small signal circuits. Already I told you, small signal circuits are devices, correct? Transistor, correct? I said transistors are there, diodes are there. Then you can field effect transistor, correct? Then you have MOSFET. Then, yeah, these are the main components, correct? These will be put inside the IC, integrated circuit, starting from hundreds to millions. These in which for these IC transistors, individual transistors or individual amplifiers or whatever it may be, using this one, you apply, I told you, maybe 5 to or 3 to 50 volts maximum voltage. I told you, you can use the 0 to 3 volts, 0 to 5 volts, 0 to 12 volts, right? Or 0 to 20, right? Generally 50 is still too high. Generally they restrict up to 24 volts, something 30. If the voltage operation for this circuit, we call a bias voltage. Please note that we bias the transistor last semester. Right, correct? How to bias a transistor using resistor, the voltage divider circuit, all these things. We saw that biasing is needed with a DC voltage. Bias the transistor with the DC voltage. It can be biasing transistor or FET or MOSFET or IC, integrated circuit, correct? Op amp, all those things, we were supplying less voltage, less than 30 volt, 20 volts. That is called a small signal circuit. The current consumed will be in the order of milliamps, less than amps. Generally, in the order of milliamps to microamps also. Okay. But that is called small circuit. But if I wanted to, this, so what way we are using? Op amp for amplifier, amplifying signal from sensors, correct? Strain gauge bridges, correct? Or from the thermocouples or RTD, lot of sensors. What is the output of this one? Output of our this one sensors, voltage rating, generally in the order of microvolts to millivolts. This is what the output of the sensor. Output of sensor will be hundreds of microvolts, hundreds of millivolts, less than a volt. That is what output from the sensor. What is the input to it? Measuring parameter, temperature, pressure, force, correct? Temperature, force, all those things are whatever parameter, your humidity, light intensity, all those things, that value will be converted into electrical signal. The sensor convert the physical quantity in electrical signal. The electrical signal will be in the order of microvolts to millivolts. This signal cannot be directly going to your microcontrol system. So what did we do? We used the amplifiers, correct? Amplifier amplifies the micro millivolt to volts, not in hundreds of volts. Amplifier, what it does, the sensor signal will be converted to microvolts, millivolts to 0 to 5 volts, 0 to 10 volts, not 0 to 1000 volts, 0 to 100, 200. The output of op amp itself may be 0 to 10 volts, or plus or minus 0 to 10 volts. Right? That's what I do. Input was in millivolts. So for example, 0 to 1000 microvolts or 0 to 500 millivolts. Some sensor that is given to amplifier. Amplifier input bias voltage was 0 to 24 volts, 0 to 12 volts, or plus or minus 12 volts op amp. You give it, the output also will be this one. Anybody, what can be the, for example, I have an op amp, correct? I have an op amp, I give plus 12 volts and 0 volts. Okay, I am giving input voltage, this is plus minus. You know that inverting, this is a thermocouple TC, it generates 0 to 50 millivolts when the input temperature varies to 0 to 1000 degrees centigrade. What will be the output voltage? V out, maximum output voltage. Anybody? And I say that the AD, differential gain, is 1000. Correct? What is the output? We know that this is called V plus, V minus. Correct? This is called V minus, two input. Non-inverting input, plus is called non-inverted. V minus or minus input called inverting input. What is the output voltage? V naught equal to, anybody? I said this is gain of the op amp. Please answer. When asked question, don't keep quiet. We are in the real live class. It is not that one way listening to some video and just go away. Next class, I want you all have to switch on your cameras. I want to see you. Anybody? I am audible?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
No, please switch on your cameras. I want to see the faces. Here afterwards, I want all of you to switch on the camera. I want to see the faces. Whether you are in the class, I want to see. It's not just switch on and just log in and go. Because this happened. Nobody answers. But then I think that, in fact, BTech in Corona time happened. I had 120 students. My 110 students will be logged in. Ask, nobody answers. Ask the switch on the camera. They say my camera bandwidth is not sufficient. This is another storytelling. Correct? If it's not there, also it will come and connect and go. Don't worry. Correct? Nobody answers. One day, I forced to answer. Except 20 students, nobody is not in the class. Everybody logged in, sleeping, something they're doing. Every day this was happening for more than 1.5 years. And the teacher will be preparing and coming and sitting. What is the use of them? What is the output? We are talked about, because these are all important. Don't say the last semester I wrote exam, I forgot. You are not completed your degree. You are in the 4th semester.
No, sir. Sir, we are discussing how to we remember.
No. Why discuss? It is not discuss and tell. Individually you should know. Instant you have to tell. Already you passed the course with S grade, A grade, B grade. Correct? Last semester, just not even 6 months before. I want somebody to answer. Otherwise, I will not move. There's no point. I am not like other teachers. I want to answer interactive. Otherwise, what is the point? Is just I come and blasting in the this one. You just hear or switch on and go. No, you don't answer any question. What is the use of teaching? Instead that you can take a book and read yourself. There's no teacher is needed. You can somebody gives some question paper, some clerk, you write the exam, and somebody corrects it as per book, whether line by line see, then teaching is not needed. What is the output voltage for this APAM? If I give this, I want to know, because power electrons also like this only. If you don't understand the last semester, what you are going to understand this semester?
No, it should be 5 volts of the output.
How? What is the formula? First you tell me the formula. At least you are able to tell something, I am happy. Okay.
Gain into input.
Pardon?
It should be the gain into the input. So gain
what is the input?
0 to 50 millivolt is the input you said.
Yeah, 0 to 50 millivolts. So what is formula? Tell me this one. What is the actual formula? APAM actual formula.
Yes, sir. AD into the input, sir. Maximum
AD into
input.
Delta V in. I said
sir.
delta V in. What is delta V in?
50 millivolts, sir.
That is 50 millivolts. But actually, what is formula? APAM formula. Output formula, somebody should tell. It is very simple. Don't say that I forgot. V out equal to V plus minus V minus into AD. This you don't remember. There are 40 students. None of you remember. Some of you got S grade, A grade, all those things. I taught about it for 10 classes, starting from basics of APAM, input parameters, as an amplifier, differential amplifier, non-inverting amplifier, inverting amplifier, instrumentation amplifier, filters, everywhere APAM was there. This is basic formula, correct? This is called as, what is the output? What is this condition called? Open loop or closed loop? This amplifier, what I have done, is a open loop amplifier, closed loop amplifier.
Open loop, sir.
Open loop.
Why open loop? If it is a closed loop, how it will be? Can somebody say? I will draw. If you say, I will draw.
Sir,
Okay, already drawn APAM for you.
Sir, closed loop, sir, that out from output gain, there will be a connection, sir.
What connection? Tell me. Very good. Thank you. At least you are able to tell. Remember this much. How will you provide? What is called?
Sir, we will take the
negative feedback.
It is called as negative feedback.
Okay.
Yes, sir.
Negative feedback. Okay. There are two inputs. This is a V. This is V plus. This is V minus. Then this is plus
Sir,
V supply minus V supply.
Sir.
Okay. This is V out.
From
tell me the
V
connection.
out, from V out, we have to take one connection, and that is the feedback resistor, which will go to the negative terminal.
Take output, then one resistor should be there. Output.
Resistor, RF.
Resistor, or can it be connected directly? Is it allowed? Output to the, which one to I have to collect? There are two inputs, V plus V minus.
V minus you have to connect, sir.
V minus, V minus,
V minus.
V minus, sir.
V minus.
Yeah. Okay. Then this is my thermocouple. Plus minus. This is my TC. Okay.
And
this
one for ground also.
Yeah. Which one should go to ground?
The negative, same negative, sir.
Same negative should go to ground to one resistor.
Yes, sir.
Yes.
Correct. So what is this resistor? This is called feedback resistor. This is called as R input resistance. Of course, for V plus also there will be one more resistor, correct? That will be same as Rin. So if this resistor is 1000 ohms, this also will be 1000 ohms, which is connected. This resistor connected this one both. And what do you got? So now if I connect, what is formula V naught equal to? Franklin.
Is V0 divided by
No,
V0
I am asking Franklin. I am asking Franklin, not you.
Oh, I'm sorry.
V naught equal, what is formula for this? See, but the thing is that I'm not trying to tell you only. Correct? Anybody I'm asking, correct? You did one semester prepared, then how you are going to remember, use it in your workplace or this one? What is the point in doing a course? Simple. Huh? So we know that what is this amplifier? Can say, for example, send them in. Can you say? What type of amplifier is this? Inverting, non-inverting, differential, what type of amplifier?
It's a non-inverting amplifier, sir.
Fantastic. Why you are correct? Why it is called? You are correct. I will give 200 marks. Why it is non-inverting?
Negative feedback.
Non-inverting means sir, whatever input we are giving, sir. Basically, that is not getting what I want to say. Like suppose we get we give 10 milliampere of voltage at the input. Okay, so non-inverting means it will get amplified with keeping the same phase in that sense. What I mean to say,
you are correct. You are correct. But
yeah,
you are all your answers are correct. But you are not telling the point why it is called non-inverting.
The negative feedback. We are
because RF
connecting
is
to
connected to negativeness,
minus.
sir.
What?
P minus.
I am taking
RF
the
is-
output and connecting it to negative, right, sir? So
P minus.
That is called negative feedback. That is negative feedback.
Sir,
Please note that we know
Sir,
what are the
both
different.
input-
1 minute, I will tell you. Good, nice. Last semester course I am teaching now. This semester I will teach next semester. Don't worry about it. I will conduct the this one. What do you call the hybrid electric vehicle next semester also. Repeat the course for you. But my thing is whatever taught you should remember throughout your life. We know that one is called as inverting amplifier. Using op-amp, these are the possibilities we studied. You wrote exam. Some of it got systematic, but we forgot within 2 months or 3 months. Other one is called non-inverting amplifier. Other one is called differential amplifier. Then we had instrument. These are the 3 instrumentation amplifier. These are the amplifier we studied. For all those things, you need an op-amp. If we say negative feedback, these two resistors, this resistor connected to output, this resistor connected to ground. What I told, this is called as, I spend a lot of time because anything if I teach you, after 10 years also you should be able to tell. That's how I learned. Many things I learned 40 years before my BTech class. Still, I never studied once again. Still, I remember. Because I listen to what my teacher is saying. Not only writing, remembering this one, and you have to put it inside mind. I not that erase next exam over, I erase clean board. Why no blackboard? Erase with water. Again, next class, erase. No. It's your brain has 40 billion neurons. How many? 40 billion neurons. Each neuron can store 1 bit of information. We are Einstein, people say that nobody can exactly measure. Doctor cycle together based on Einstein, this IQ, all this one. They say he used 2% of his brain. He is a Nobel laureate. He is a polymath. His theory, nobody is able to break even after 60 years. Theory of relativity, general theory. People, thousands of scientists are trying to disprove that what he told is wrong. Theory of relativity. Still nobody could do. Correct? They say he used only 2% of brain. I don't know whether I use 0.01% or 0.001%. Correct? So we have a lot of capacity to keep it inside, store information. Fine. So all these things, if you say amplifier closed loop with negative, what is what? Closed loop feedback. What type of feedback? Negative feedback. Op-amp, this is called a open loop feedback. Already told you. If I connect a thermocouple TC here, this is plus and this is minus, this is power supply plus Vs, this is minus Vs, this is my output V0, right? So this is my TC, gives 0 to 50 millivolts when temperature varies to 0 to 1000 degree centigrade, for example, chromodome or something. And if I connect like this, if AD equal to 1000, previous to this one, what will be the output? V0 equal to AD into V plus minus V minus, that is what output. I am saying when the temperature 1000 degree, my thermocouple produce 50 millivolts. I can say that V0 equal to 50 into 10 power minus 3 millivolts multiply, right? Multiplied by, what is it with this one? I am connecting input to this one, 50, sorry, very sorry, this is 1000. AD is 1000, extremely sorry. VD, this is 1000 is nothing but my AD, already defined here, right? I say AD multiplied by V plus is 50 mils, because please note that thermocouple has a two output, any sensor, one cell, one output is called plus signal, electrical signal minus. Electrical signal plus minus will be there. AC means it also no plus minus, but it has two leads. Okay, with reference to one lead, other goes up plus and minus. So this is what is coming out. The plus signal of the my thermocouple is connected to V plus, which is called a non-inverting input. Correct? Minus of the signal is connected to minus of the this op-amp, which is called an inverting input. This is called V minus, this is V plus. So this is called as, we know that op-amp always amplify differential signal. Why? Already told you, this is called a delta V in. Delta V in is nothing but voltage applied to V plus minus, V minus is called difference voltage. Op-amp always amplifies a difference voltage, whether it is a open loop or closed loop. I will come back. Okay. Now we are given to this. So here 50 millivolts is given. So 50 into 10 power minus 3 volts minus the V minus 0 volts. So I can write like this. Sorry, I can write like this. 1000 into 50 into this. 50 minus 0 is automatically 50 only into 10 power minus 3. So this 10 power minus 3, this will go. 1000, 10 power minus 3 cancels. So my V0 equal to 5 volts. Okay. This is called a open loop amplifier. Okay. But what is the drawback of open loop amplifier? Anybody? Why we go for negative feedback? Anybody can tell, because we talked extensively. I remember this one. I spent almost 1 week or something.
Noise. It will, what I mean to say is, if you are having the like non-inverting amplifier.
Sir, it will have reduced distortion and improving the stability as well, sir.
Yes. 2, 3 things. All 3 are correct. What Roshan told is correct. Correct. That is also correct. It removes noise. And also, but please note that this amplifier also removes noise. The input signal is a differential V0, V plus minus V0. So that means it op-amp automatically removes noise. Of course, with closed loop also it removes noise. More important is reduce the distortion. One thing. And another thing, one of the most important thing, Arnasalam, want to tell something. You want to tell something? What is the advantage of closed loop amplifier? Negative feedback. Distortion, noise reduction, both they are told.
One more thing is the
Stability, sir.
Stability, sir.
Stability, that is correct. What stability? Fantastic.
Less
nice.
oscillation. Less oscillation, sir. Less
That is
oscillations.
that's correct. More than that, what is AOL? What is AD or AOL? AD or AOL? What AOL?
Open loop gain.
Open loop gain.
Open loop gain. Yeah.
Open loop gain is temperature dependent parameter. What should be value of AOL or AD in theoretical amplifier? Theoretical amplifier. How much?
It should be infinity, sir.
It should be infinity. And practically, how much should be generally available?
It will be 10 to 10 power 5, 10 to power 8 in the range.
10 to 10 for 8. Okay. So now,
so that
already
means,
told you.
Sir, we are remembering something, sir.
What?
So we are able to recollect many things that you have taught us, right?
Yes. You are able to recollect. I am very happy. But you are not telling. Correct? What I say when I ask, if you tell, we are happy. We will. I will be
Suddenly
happy if
it
you are able
has-
to remember and tell me. Remember not
Suddenly it
only
is.
now.
Sir, you know the story of Hanuman, na? He
Yeah.
forgot his powers and then Jaman told him
Yeah,
that you
whenever
can
we say Ram, power increases 10 times,
Right,
and
sir.
he power increase 10 times. Very good. At least I am able to tell Ram and your power is increased. I am very happy. Good.
Thank you, sir. Thank you.
Okay, fine. So the
Thank you,
most
sir.
important thing is stability. What you get the AOL change, drift of AOL. Correct? It is called temperature drift.
No.
Temperature drift of AOL is there. And I said, if I say mu741, correct, is AD or AOL, open loop gain is 10 power 6. It is at, say, for example, 29 degrees centigrade. That's what the manufacturer says. If temperature goes up, the gain increases. If temperature goes down, it comes down. It is like temperature drift of beta of the transistor. What is inside your op-amp? Again, transistors. Transistor, individual transistor current gain, which is called beta, it is a temperature dependent parameter. Beta of the transistor can be 10 to even 1 lakh. Correct? I told you, super beta transistor has gain of this one. What is the amplifier gain? How it amplifies? If I give IB is called as input, base current. Correct? It is input. What is the output? Collector current, IC. IC equal to beta times IB. Beta is called as current gain of a transistor. Who decides the gain? The manufacturer of the transistor. But it is available range from 10, beta equal to 10 to up to 1 lakh also. Correct? Since 1 lakh is a very big number, most of the transistors will be in the order of 100 to 2000, 3000 within the range. Please note that there are 10 to 20,000 different transistors manufactured by the transistor manufacturer. There are hundreds of companies around the world. There are semiconductor manufacturers, transistor diode manufacturers. They make more than 10 to 20,000. We know what are the important parameters of transistor. Transistor parameters: VCC max, correct? VB max, IC max, collector current max, IB max, and beta and PT, power transistor can dissipate without burning itself, because there's a heat generator because I square loss inside this one. These are the important parameter, transistor parameters, correct? And if you are selecting a transistor for amplifying a signal coming from a thermocouple or a sensor, I wanted to give it to one transistor amplifiers. Already we know that, correct? Where you will give, this is called RB, this is base terminal. This is what type of transistor this is? Anybody can tell? This is plus V, this is VCC, this is supply battery, and this is collector, this is emitter, this is base. We give the input at the base. This is called Vin. This is my TC. It gives 0 to 50 millivolts when temperature ranges from 0 to 1000 degrees centigrade. Same what we talk about. So if I connect this 0 to 50 millivolts, so there will be a current going. This current is called IB. Who is supplying a thermocouple. That is because it is voltage produced by thermocouple. Current is a byproduct of the voltage produced by sensor. Sensor produces only voltage, which is called EMF. Correct? That depends upon temperature, subject junction temperature. Correct? So it varies. Now that is given as input to my transistor where in the base of the transistor. And due to this, there's a current going. This current is called as IB because the current is entering. What is formula for IB?
Is VB minus 0.7 divided by R.
Yeah, V in minus 0.7.
Yeah.
Sir, then it will be VB minus VBB, right? We could
Which one?
write it as VB minus VBE minus VBB, right?
Yeah.
0.7 will be VB.
No,
VB.
you can directly give sensor, but good thing, nice thing, fantastic. If I connect the this sensor directly, what will happen? I told you the sensor produces 0 to 50 millivolt, correct? Whether there will be any base current for the what is base current formula? IB equal to, very good, nice. I am very happy, extremely. Who is that? Amita?
Yes, sir.
Okay. IB equal to V in minus, correct? VBE divided by RB. RB is the, what is RB is called as? This
Base
is RC.
resistance.
Base bias resistance.
base bias resistor.
What is RC?
Collector
Collector resistor.
Collector current limiting resistor. Or bias resistor say generally is a collector collecting resistor. Correct? These two are you are going to connect. It's not part of transistor. This is used for protecting your transistor. If it is not that, IC, if you supply more current and base and beta is the transistor gain, I say 1000, correct? And high current will go if you don't limit. Already we know the ICC max for each transistor is given. VB max, for example, 30 volts. Sorry, VCC max, this is 5 volts. IC max, 1000 milliamps, correct? IB max, maybe 500 microamps. I am saying microamps, correct? Beta equal to 1000. This is equal to say 500 millivolts. This is the transistor manufacturer given. For example, BC 107 is the transistor, correct? Already we discussed external, but still I wanted to review because this is very, very important parameter. Should not. Okay. Now, if I give directly what happened, what is the current now? We are giving 50 millivolts, correct? I said TC, if TC produces 50 millivolts, if the junction temperature is 1000 degree. I said that my junction is 1000 degree. What is the VB? Sorry, Vin. That is sensor output is your Vin. That is going to 50 millivolts. Millivolts means 10 power minus 3 volts. Okay. What is the VBE? If transistor has to conduct, it should be greater than 0.7. Okay.
Yeah.
Now, this minus 0.7 divided by my RB equal to, for example, I decided to put this is 1000 ohms. Correct? So this is 1000 ohms. Any current will flow?
It should not, because it has to be greater than VB.
It is not there. So now if I connect my thermocouple directly, if I vary my temperature 0 to 1000 degree, my sensor gives 0 to 50 millivolts only. If temperature is 500 degree, it gives 25 millivolts. Correct? So now if I directly connect it to my transistor base, whether I will get what is output? Output is IC. IC equal to beta times IB. What is beta? Beta equal to 1000. What is my IB when temperature 1000 degree? 50 millivolts.
It should not flow at all, right?
That's what I'm saying. If I connect directly my sensor, my transistor amplifier is absolutely no use. It is not going to amplify, even though it has a gain of 1000. The base current should be multiplied by 1000 times. That is output. IC is the output. Output is 0. Because the input voltage, this is called a distortion. This is the distortion, but up to 0.7 volts, if my signal, sensor signal less than 0.7 volts, my amplifier, transistor amplifier, this is called as transistor amplifier. Transistor amplifier won't amplify. Correct? This is called as, correct? This is called as class C amplifier. Okay? So that means your input voltage is greater than 0.7, then only this amplifier can be used. Then, if I want to amplify the thermocouple, is there any way to do? You may ask. Then what we did? We did voltage divider network. If you remember, we put a voltage divider network like this. This is my V0. This is supplied with VCC. Correct? This is supply voltage. This is connected to collector, emitter. This is RE. This is RC. This I call R1. This is R2. This is my VB. What is my, now I am giving, for example, 10 volts. What is my VB? Anybody remember? I think last time at least 5 to 8 people did this nicely. They got full marks also in the NSM exam also. What is VB? I saw.
VB will equal to, sir, VCC multiplied by just a minute. Multiplied by RC divided by R1 plus R2.
No, RC, you are making some mistake.
So,
R2
sorry,
divided by R1 plus R2.
R1 plus R2. Right, I'm sorry.
This is called a voltage divider network.
A Thevenin version, sir, if I'm not wrong.
Pardon?
Thevenin, sir.
Yeah, Thevenin's correct. I remember, that's why I'm waiting. Because I think you attempted, you got full marks. If I'm correct.
So it's okay, sir.
No. I'm not telling anybody. I'm not trying to say others are not good. What I'm saying is, You remember at least, okay. Others also remember, they are not answer. That's okay, fine. I'm not trying to say you are not good,
Yeah.
is not nothing like that.
Of course, sir. Of course.
I
Thank you, sir.
remember that you answered this question. I see just 3 months before. I remember most of the which student attended what questions still. Answers are not with me right now, but still I remember. V Thevenins, correct? We call this as V Thevenins, correct? Then we did like this. This is V Thevenin voltage and R Thevenin, correct? R Thevenin, that is what is going to be transistor base, correct? This is going to be IB. IB will be V Thevenin divided by R Thevenin. It will be IB. Many of you, not only you, I at least that's what I told you. Even before also I said 5 to 10 students wrote very well. And, still I remember. That's why not only you, others also. They are not added. That's not this one. Okay. So now if I do this, already we are supplying some voltage. VB is called a bias voltage. It is called as base bias voltage. Now, according to this formula, what will be VB? For example, this is 1000 ohms. This also 1000 ohms. What will be this voltage VB or V Thevenin? Is going to be 1000 divided by 1000 plus 1000 multiplied by this is I said 10 volts. So this is going to be 0.5 multiplied by 10 is going to be 5 volts. Already 5 volt is here, right? I already 5 volt is here. I say that my computer R Thevenin equal to, for example, 500 ohms. Okay. V Thevenin equal to this, what the voltage we calculate. This is 5 volts. What is IB? IB equal to 5 R Thevenin divided by this one is going to be 500. So many amps. I can say that this and this will go 1. So 0.01 amps or 10 milliamps current is going. IB equal to 10 milliamps. So what will be the IC? IC equal to beta into IB. Okay, that is going to beta is 1000 into 10 into 10 power minus 3. Okay, 10 power minus 3, 1000 goes. 10 amps current should go. That means the 10 amps current will flow inside the collector to emitter. The circuit will be closed. Then what will be the, this one? Power transistor, anybody? PTR. Power dissipated across the transistor due to the, what is the current? IC. IC equal to 10 amps. Correct? PTR equal to VCE sach. Anybody remember? VCE sach multiplied by IC. VCE sach how much? See, we know the VB equal to conductance as 0.7 volts. Similarly, VCE sach when transistor fully conducting at a full current, that will be 0.2 volts. Correct? That will be 0.2 volts. Please remember, if transistor is conducting, if IC is flowing, how do you know transistor is conducting? IC equal to not 0. IC equal to not 0 when? At what condition? When IB is not equal to 0. Correct? When is IB is not equal to 0? When VB is greater than 0.7 volts. Please note that this all this thing we did extensively last semester. These are fundamentals of electronics. Now, after doing mechatronic course, you are not a mechanical engineer. You are a mechatronic engineer. You know electronics. You also know mechanical already. Your field of BTech already did. Correct? Now you also did electric also did. Now you are doing additional course. So why I'm telling all this? So this is how it works. Now the bias current is already flowing. Now if I give my thermocouple, correct? What I will do? I will connect my thermocouple like this. Already my biasing is there. I clear all other things. You will be able to see that what is going on. Why I am telling is why biasing is needed. If I want to amplify the sensors whose input voltage microvolts or millivolts, if I directly connect to my base of the transistor using this circuit, which circuit? This circuit. Correct? So without base bias. This says without base bias. This circuit is without base bias. Let me clear other things you will see. Even if it takes time, no worries. We can cover the portion. My whole policy is if I teach something, even some 3 to 4 topic, you should remember clearly. That is my whole idea. Now I will clear all those things. You will see what actually. This is also amplifier, but only problem the amplifier is without base bias. I don't have base bias. I have a transistor. Collect is bias. Why I say collect is bias? Anybody? Base is not bias. Collect is bias. Somebody can tell. Nothing wrong in it. If you don't all see, you are now only learning electronics. It doesn't mean that you should know everything. You did only one course last semester. My whole idea is whatever you learned last semester, you should remember. That's what nothing. But you are not done a 4-year BTech electronics or electronics where you study 5 to 6 courses. You are in the learning phase. Nothing wrong in it. Correct? Because we call this as collector bias, base not bias. Why? Please see that I am giving VCC. I say for example 10 volts. Collector is supplied a plus voltage through the load resistor. This is my collector. So between the emitter is connected to ground, battery negative was VCC. This is my VCC. Then I connected to emitter, which is connected. Collector is given to say for example 10 volts. I am given 10 volts. We know that if VCE, this voltage is called a VCE between the emitter and collector. That is what VCC. If it is greater than 0.2 volts, then I say that my collector to emitter is forward. It is biased. Correct? It is biased. But base, do you have a DC voltage? I already told you what is biasing. Supplying a constant DC voltage as suggested by the manufacturer, which is called as VCC max. VBB max, correct? He says 30 volts is this is 5 volts or 7 volts. That's what manufacturer says. If I supply this voltage within 0 to 30, not 0, it should be greater than. And if the base voltage is greater, VBB is greater or VB, some books say VBB is greater than 0.7 volts. I know that this is base junction, this is emitter. This is forward bias. Base emitter junction is forward bias. Then if the voltage between the collector and emitter, which is called a VCE, is greater than 0.2, then I can say that my collector to emitter junction is biased. It is not forward bias. I say it is biased. Another condition, anybody remember what should be the voltage? This voltage between these two, VBC or VCB, or because voltage between collector and base are base and both are same only, correct? What should be the voltage? Any idea? It should be equal to or smaller than, greater than VBB. What should be? VBE. Any idea? And I will put around VCC should be greater than VBB. Do you remember that? That means base collector voltage is 12 volt, means base voltage should be minimum 1.2 volts less. How much the maximum VB can be? This voltage can be 10.8 volts only. Then only the transistor will work as amplifier. But whether we are given any voltage to base of transistor? No, correct? We are not given any voltage to base of transistor. I say that base is not biased. Base is not biased because I have not given DC voltage VCC. What is drawback? Because of that, if my sensor voltage is correct, any sensor whose voltage output voltage is less than 0.7 volts, right? If my sensor voltage is less than 0.7 volts, the signal will not be amplified by this transistor amplifier. It won't work. In that case, what I have to do? I have to use this one. Base also bias. This, what is the other name we told? It is called as self-biased amplifier. Self-biased transistor amplifier. What is it? Why it is called self-biased? We know. Again, I am for your understanding. I am not going to ask any questions. I will just tell the information and move forward. Try to grab it. Okay, that's what, nothing more than this is my VCC, this is my collector, this is my emitter. Emitter is connected to battery negative of the VCC, positive of the is connected to collector. What type of transistor? This is an NPN transistor. How do you know it is NPN transistor? Collector is given with a positive VCC. Emitter is connected with negative VCC. Transistor symbol also, arrow of the collector terminal is coming out. Okay, collector emitter, this is my base. And we need to give two power supplies. We know that. One is called VBB plus minus. For NPN transistor, VBB, the second power supply, a DC power supply, positive should be connected to base. VCC, the positive terminal should be connected to collector. And the emitter should be connected to negative of both the power supply. Correct? This transistor is called as, what is called as common emitter amplifier. Last, this is a method of common emitter amplifier, which is called as CE amplifier. Correct? It is called as CE amplifier. Input signal, B is called as input signal. The output coming from this one, we call it V0. From the collector, this is output. So input is given at the base with respect to emitter. Emitter is connected to ground. And again, the output is taken from the collector. So that's why the emitter is a common term for the both. This is my output, this is my input. Since both input output are with respect to emitter, which is ground, we call it a common emitter amplifier. Correct? Common emitter amplifier, whether there are common base and common collector, whatever it may be, the base terminal should be given with bias voltage, which is called VBB, which should be greater than 0.7 volts. VBB should be, VBB should be greater than 0.7 volts. Then only the base emitter is forward bias. One condition for transistor to become a conduct and amplifier. Other one is, we have already told you, VCB should be lesser than VCC. Or I can say that VB should be smaller than VCC. How much? 1.2 volts. Then only the transistor will conduct. That means you need a two power supply. That means sometimes you have only one power supply. How will you bias your transistor? You can bias using what you call a self bias. That's what I showed. This whatever I'm teaching today is not part of your exam or for this semester course. Correct? Hybrid electric vehicle, I'm not going to ask all the transistors. This what I am talking now. Of course, power amplifier. Please, why am I again discussing? Again, power amplifier also, what we are talking to driver motors. Correct? Which is called actuator. We need high voltage, high current. Correct? We saw the induction motor, BLDC motor, or synchronous motor. That will be your prime mover in electrical. This one. There, you will be using power amplifier, right? But the power amplifier again is a transistor only, or it can be a MOSFET or a transistor. Only difference, instead of using 30 volts something, the power supply VCC will be in the order of 400 volts. It can be 600 volts, or it can be 300 volts. Correct? It can be anything. Again, same transistor. Only thing, this transistor needs to handle higher current and higher voltage. What will be the IC? IC will be in the order of 100 amps to even 500 amps. Not milliamps. That is why these amplifiers are called as power amplifiers. Please think that you may be wondering, sir, you have to teach something you have started last semester one. I am pulling last semester. The transistor basic, all those things. Again, we are going to talk about amplifier design, which is going to drive a motor. Correct? It can be a BLDC motor or a synchronous motor or some other motor where the collector needs to supply how much voltage? 400 volts, 500 volts, 600 volts. And the current in the order of 100 to 500 amps also. That depends upon how much current is needed. Correct? Your motor power. Correct? Motor power, we talk in kilowatts. Correct? For example, you have a Mahindra or somebody making this one, 100 kilowatts is the motor power. A pure electric vehicle. 100 kilowatt, you are using BLDC motor. What is the motor? That means that is nothing but 1 lakh watts. This is equal to 1 lakh watts power motor power, which is driving, is 1 lakh watts. Okay. We know that the power PM is nothing but VM multiplied by IM. What is VM? VM is nothing but motor voltage, supply voltage. What is IM? Motor current. Correct? This motor current. So, what is the motor power? Is nothing but product of motor voltage and motor current. Already, your car weighing around 1500 kg, correct? Or 1200 kg. It needs to accelerate 0 to 100 kilometer speed. Up to not only acceleration, it has to sustain, maintain the speed up to 150 kilometer per hour, 120 kilometer. That means your power delivered by motor will vary from 0 to 1 lakh watts. Correct? As you press the accelerator pedal, before pressing accelerator, motor is just running. Idle condition, motor is not engaged with the wheels. Correct? It is neutral. In that case, motor is running without no load condition. It may be occupying maybe 1000 watts because it has to overcome the friction of and inertial mass of the rotor. Correct? Motor rotor is rotated. It has, for example, 20 kg. I'm talking a big motor, 10 kg weight that is connected to your transmissions to wheel. So 100 kg or say 20 kg mass, friction, bearing, all this even in the neutral, this one. So it may be consuming some 500 or 100 watts, 1000 watts power. Motor is consuming at no load condition, idle condition, no load or idle condition. Okay. That means, please note that that time you are supplying your motor. What I said, motor power already they showed 1 lakh watts, 1 lakh watts or 100 kilowatts. Motor is said the motor VM. VM they say 500 volts. You have taken a motor, a BLDC motor, which is used in your electric vehicle, which is 500 volts. And what will be the IM? PM is already known. PM is 1 lakh watts. So IM equal to PM divided by VM. 1 lakh divided by 500. These two zeros are gone. This is 2. You see that current is 200 amps. When you are accelerating your vehicle or driving your vehicle full speed, that time it develops 100 kilowatts or 1 lakh kilowatt. That time the applied voltage is 500 motor because you have LI, lithium ion battery pack, which produces 500 volts that is connected to this your motor through your power amplifier. Correct? Why I'm talking is not that just for the sake of asking last semester questions I was asking. Of course, up and also these are basics. So this is my power amplifier. Correct? There are generally there'll be a backup transistor connected in parallel, but for example, you have a single power transistor which is connected to your motor, BLDC motor. This is my BLDC motor. What is capacity? 100 kilowatts or 1 lakh watts. And it is supplied to my LI battery, lithium ion battery, plus minus, this is 500 volts. Correct? Lithium ion battery pack that is connected to BLDC motor, 100 kilowatts, and the motor manufacturer says VM is 500 volts. If motor manufacturer VM is 500 volts, you have to give exactly 500 or less only. Your battery pack power cannot be more than 500 volts. Already told you, this is called a load. What is this? Load to the power transistor. Load to power transistor. This transistor is called as power transistor. It can be single or 4 or 5 transistors connected parallelly. We'll see about later. You think that is single transistor. This is same as your small signal. In small signal transistor, what you have? This BLDC motor, the coil has resistance, motor resistance, like an RM. RM motor manufacturer says, for example, 0.1 ohms, 0.5 ohms, sorry, 0.05 ohms, correct? RM can be 0.1 ohms or RM can be 0.05 ohms. Please remember, I'm talking less than 1 ohms because why? The power I am talking about 100 kilowatt. Okay. Now that is the current moving. This is motor current, which is nothing but IC. Who is supplying the current? Battery. This battery supply, say I battery, is nothing but IC, is nothing but IM. All are same because from the battery power supply, when the transistor is conducting, current will flow from here to motor, enter into transistor collector. This is a collector, and this will be connected to this. Okay, current will enter, flow through, circuit is closed, current is flowing. This is my IM equal to IC, also sometimes called collector, IL, load current. Why? My motor is a load. Motor resistance, coil resistance is the load. So that means I wanted to control. That means IC. IC needs to be controlled. Correct? Now, how much current IC should be? IC should be equal to 200 amps. You have to select a transistor whose IC max is 200 amps. VC max equal to 500 volts. Okay. Then then only it will be able to drive this motor. Okay. Then the drive current will be coming. The input of V in will be coming from your controller. Controller is going to supply V in to which is called a VB. So this is IB. This is my RB. Okay. Now I say that my transistor gain equal to say 500. Beta equal to 500. Correct. What should be RB value? Any idea? First of all, you need to find out IB. Correct? We need to, because we are started talking about power transistors. Correct? I'm just talking about power transistors. So what is my this one? This is called VB, which is control signal coming. I have the motor controller. Correct? Motor controller, which is supplying a VB to the base of transistor. This is nothing but my driver demand. You are pressing a throttle pedal. Correct? Throttle pedal. You are pressing. Correct? This is my TPS sensor. This is my TPS sensor. So TPS sensor gives input. This is motor controller. It produces VB. That VB will be varied from 0 to, for example, 50 volts. It can be 0 to 50 volts or 0 to 10 volts, something like that. Correct? That is given to base. Due to that, there will be IB. Correct? This IB, that means the transistor has a beta. IB multiplied by beta is nothing but IC. Already I do. If I want to drive my motor full speed, motor current should be IC. IC equal to, already we computed 200 amps. 200 amps equal to IB multiplied by beta, I said 500. Correct? What is my IB? IB equal to 200 divided by 500. Correct? The zeros are gone. 2 by 5. Correct? It is going to 0.4 amps. IB should be 0.4 amps. Okay. So if I then current already know. My controller voltage is coming from my motor controller. Correct? Motor controller will produce what is voltage? VCM. Control voltage. Correct? Will vary from say 0 to 5 volts by my controller. Are you understanding? Because just there's no point in I'm talking. Any idea? So.
It's okay, sir. Please carry on, sir.
Okay, fine. So I will explain later since we are doing this. And 5 volts, when 5 volt is there, when controller is 5 volts, what a current should go? Already we calculated 0.4 amps. IB should be 0.4 amps. Correct? So my RB equal to, correct, VCM divided by IB. VCM maximum voltage 5 volts. Correct? When motor has to deliver 100 kilowatt, when vehicle is running 140 kilometer, the command input signal should be 5 volts. Already we told. So 5 divided by 0.4 will be the RB value. Correct? So 5, 4, that is. Fine. 0.5 means this is at least 10, something around 12 something. Oh. $12.5, correct. Okay. 12.5. This should be 12.5 ohms. So this is how we design the power amplifier to drive the motor. Okay. So I think time up. I will stop here. Anyhow, this is part of the power electronic devices. We will talk about power transistor, all those things. And I will stop here. Tomorrow we'll continue actually after rectifier. Actually, we wanted to talk about rectifier circuits, but we were talking about the op amp last semester we brought in, and then we were talking about power amplifiers. Okay, I stop here. Please give your attendance before leaving.
Yes, sir.
Sir, sir.
Yeah. Please tell me.
but tomorrow our project review is there, sir.
Okay. Tomorrow project review, I think goes up to what time? Any idea?
6 o'clock, sir. They put up to 6 o'clock.
Yeah, they can be go plus or minus also. Somebody
So up to 6:30. Up to 6:30. If it is close now, then we will connect at 6:30, sir. After 6:30 means then we will not able to connect. Sir. That's
No,
why.
I think who is the last candidate? Sorry, I want to. So, please,
Today?
you 2024 batch can just can log out. You can go home. Please give your attendance. Just I will talk with 2020 regarding tomorrow Viva. 2024 batch can give attendance. They can leave. Just few minutes. I will talk with these people. Thank you. See you.
sir.
Okay, sir.
Whether class will be tomorrow or not, my Chidambaram and as well as Arunachal will tell the students. Okay. Tomorrow
Sure,
class,
thank
whether
you.
it is my class is there or not.
Sure, sir. Sure, sir. Thank you.
No.
Thank
But the I main thing, because you please note that you have 35 marks. Tomorrow you
Yes,
have stake of 35 marks.
Yes, sir. Yes, sir.
Correct? I know your guides will be taken. It is not my job. My job is only 4 students. But I'm just telling you that now I am no, there's no still, even though I'm not a coordinator, still I wanted to tell. Please prepare well. And you should, whatever you're presenting, you should know what you did. They will ask questions from there, some basics also. Correct?
Right, sir.
How did you do? How did you, what type of equipment? How did you take the readings? Correct? They ask based on what you are presenting. Please make sure that you show some results. Correct? If without result, talking many times already, more than half semester over, you should have completed 60% of the work. The semester beginning, because the committee will be literally very serious. If you don't do, you lose marks. Means the 35 marks is take tomorrow. Correct? So you should get more marks in each. So final, it will be 65 marks. In some, it will be in the May. After your most likely 15th, something like that will be there. That anyhow you will come to. I want to first weekend, as Arnason that they requested, I will find out. First weekend, maybe your Viva and this one, in some exam.
Second week, sir.
Second week. You want on second week. No, second week means please, that's what I want. Second week means you want on 16th, 7th, 16th, 17th.
No, sir. 9th or 10th, that's what we have discussed.
That's what I was saying. 9th is Friday. Correct? 10th, 11th.
10th, 11th.
Yeah.
So
10th and 11th, we am trying to fix your, please reserve your tickets approximately. Tonight I will tell you. Definitely I will tell you tonight. So, end some theory exams. Correct? For you, one is this one, my course, this course, for 2023, other one is Shankaram course, correct?
Control system.
Control system. Saturday will be control system on 10th. And 11th will be my subject. Morning.
So 11th confirmed, sir. Your subject confirmed.
I am confirming. Correct? I will talk with, I am confirmed, I will talk with them. Only thing, my exam for NSM will be on because 18th I will be in Germany. I'm going to Germany. I will not be here for 10 days or 1 week. Okay, I'll be returning because I'm visiting some industry as well as the university. And second for 2-3 day expo conference, and also I have to TU Damstead also for some collaboration. So 1 week I will not be there. So before that I want to complete. So 11th will be my exam. Noted. Please note down. There's no change.
Okay,
in it.
sir.
Correct?
Okay, sir.
11th Sunday, 9 to 12 will be your exam.
Sir, 10 to 1, sir. Sir,
10 to 1.
sir.
Okay, you are convenient. 10 to 1. No issue.
So,
10 to 1, my exam on 11th May. Note down. You can
Thank
tell
you, sir.
other students also. Okay. And the only
Thank
thing
you.
I need to confirm, because I don't want you to come twice, because you are coming Saturday on exam. That will be control system. Your exam on control system will be on Saturday, 10 to 1. That will be fixed
Sir,
by the, yeah, yes, please.
Sir, I think Shankaram we have to ask them, sir. That is all.
No, okay.
Okay, sir.
Okay.
No. Then that's also fine. Yes, sir. You can talk to him. I will leave it to you. You can talk to Shankaram. I have fixed on 11th.
Thank you,
It is
sir.
a physical. All of you should come. Booking flight ticket, train ticket, do it. For my exam, I am confirming. For Shankaram course, you can talk. Arnasalam, you can talk with him today itself.
Yes, sir, yes,
You
sir.
say that
Yes.
he has already fixed, because this exam is not online. Both the exam, all
Yes, sir.
three. For the 2024 batch, Professor Anand, and he is also going to conduct. He will conduct on Saturday. My
Right, sir.
exam will be a Sunday. 10th will be for your control. For other group, Anand.
Okay,
And
sir.
11th will be my exam. If you want to come 2 weeks also, for us no problem. You want to have come on some other day also, all the way 2 times 2 weeks if you want to come also good. But generally we say that 1 week, because we are giving well in advance. Prepare Saturday one exam, Sunday you can go back.
Yes, sir.
Okay.
Sir,
So
11th confirm na, sir.
mine is confirmed.
Okay, thank you,
It
sir.
will be MSB 358 exam hall also. I'm
Same.
telling you.
Yeah, same all now, sir. We are
Same hall. Last time where you wrote it, that is what it is. But for this one, you confirm with Shankaram. Now it 90 circle. You can confirm.
Yes.
And tell Chidambaram to confirm with Anand and 10th.
Right.
He has to tell that 10th already for some uneven fix, and we don't want to come twice. So we want to write exam on 10th May, and Chidambaram should talk and fix their exam. And you will fix your control sys exam over.
Right, sir.
Okay.
Thank you, sir.
Okay, that is fantastic. Nice. So that's
Thank
it.
you, sir.
Tomorrow, do well in your this one presentation, and I try to get maximum score.
One last
So,
thing, sir.
yeah.
Sorry for this happening.
Nothing happened. No. Don't say sorry. No, sorry.
Somehow we are not able to remember all these things immediately. That is why.
Please tell. I am going to tell tomorrow also. Correct?
Okay.
It is not that you don't. It is not that. Correct? This is where I teach. Ask question,
Right.
demand. You are not answering. Correct? Then you will get what is the process saying. Next class, I will come and tell the answer. I want to create nothing more than that. Nothing more than that. Correct?
Right.
Kindling, no human, but no human. When somebody in classroom asks, you are not able to tell next time, that is human nature. When I was in class, same. Hey, Manivanan, can you tell? Literally, I faced one person asked. I said, I don't remember. Without remembering, why do you coming to class? I'm talking 40 years before when I was doing BTech. Correct? Next class onwards, correct? Generally, I remember. Next class onwards, I'll be generally, correct? It hits your no. What do you call it? Personal this one. Hey, how come in front of others to they ask? It is that professor also told same thing. It is not that I am trying to hurt you. Correct?
No,
this
sir.
will kindle you. Okay. If professor asks, definitely you have to answer. You have to prepare and come. That will make you to put a lot of concentration. That will help you remember things. Do your course better even after 10 years. You will still remember. Nothing more than it. I never get angry. And if you don't say answer, I may say you are not this or all these things. I am not very hard. Correct? I said you should remember. Within 3 months, you should not forget. All these things only to kindle you only. No offense. You are our students. That's what your last sentence, what I said. You are student. Now only you are learning. Correct? You are not studied this or 10. You are not ECE background or APA. You learn 10 or 6 classes. Now only you are learning. But only thinking, I am forcing you to learn more by kindling your self this one. Correct? human nature, no? In front of class, he asked, I could not answer. So next day you will prepare and come. At least you will do. Nothing would. Okay. Thank you. Take care. Do well tomorrow. Tomorrow, what do you want to have? That you want to have class around
Sir, that is
6:30.
what-
I can start class by 6:30. No problem. Fix the
Right,
time
sir.
now itself. No
Sir,
question of waiting.
Sir, I will inform you before 10 minutes of 6 o'clock, sir.
Okay. Sir.
Right, sir.
uh,
Before
Okay.
10 minutes, sir. At 5:50, I will confirm, sir.
What time you want to start the class? Tomorrow there's a class, no cancellation. Correct. Already we
Okay.
missed 2-3 classes. I'm going to compensate.
Right, sir. Right,
Definitely.
sir.
I will try to take this. Thursday I'm going to take classes. Please note that. 2 hours.
Sir, that is after midsum, sir. After midsum.
Sir, Thursday, one more batch we have. One more batch we have, sir.
Thursday. Two.
Divide, I know that. Okay. Thursday also. Okay. Forget. Thursday you have.
Yes, sir. 2 days, sir.
20
Tuesday.
people, 27, sir. 11 people tomorrow, sir. And it's
Wednesday
12
no.
people. Wednesday no, sir.
Oh, okay. Okay. Oh, same committee in that case. Only one.
No, sir.
committee.
No. There is another set of.
One is
Then
with,
they should have fixed it the same day, no? Parallel, they can conduct complete one day. That's how I do. I don't know why. Okay, fine. There's a coordination. Generally, that's why you put 2 committees same day. Parallel will go. One day it will be over. You will be relaxing. Over. But I don't know. Because maybe constraint. Maybe that committee members did not free on that day. They may have classes. They would have told Thursday. We don't know. Fine. Anyhow. So, okay. Tomorrow there's a class. Wednesday class is there. The time tell. Wednesday regular 6 o'clock it starts. Tomorrow it may be 6, 6:10, 6:15. The compensatory class we will do next week. Don't worry.
Thank you, sir.
Okay.
Thank
Good
you.
luck for your tomorrow presentation and do well.
Thank you, sir.
Okay. Take care.
Thank you, sir.
Okay.
Thank you, sir. Thank you.
Bye.